Today, we're talking about how to measure the execution time of your Go tests accurately. So why measure a test execution time? Well, fundamentally, we're talking about speeding up your test suite, right? Oftentimes, you check in code to GitHub or your repository, and the tests run. Meanwhile, you're expecting a test to fail, so you want to wait to see the results as soon as possible. And if the test time is quite a while, maybe you need to switch to different tasks. And maybe you're just, well, I'll just wait. I'm going to go get a snack. So ultimately, it's about developer experience, right? The faster your tests run, the faster you can turn around code, the faster you can check in. And it's just a better experience for developers overall. So when you run tests, you want to know how long they execute and which one is the bottleneck, right? How to speed up your test suite so you get that fast turnaround time. So far, we have yet to find a tool that kind of gives us the information that we need, actionable information about test run times that we can use. So let's look at examples. So one of the popular tools is GoTestSum. And it has GoTestSum tool slowest, which gives you the information about your slowest tests. So let's go ahead and try running this. So I already ran my test suite, which takes about 14 minutes. And I have the JSON file for that test suite. So I can just show the how it looks. So the JSON file, so you run go test-JSON, run your test suite, and then it gives you the file. This is just the head of it. It's a really long file. So let's go ahead and run go TestSum tools slowest --JSON file. And it's right here. Core result JSON, and then we'll do there's a switch. Let me check what the switch is that we can see threshold, right? We can give it a threshold to just list the tests above this threshold. So I'll say 1 minute. Ooh, too many dashes. Okay. So this is the result. It's telling me this test, 6 minutes, 4 minutes, 3 minutes. And the first thing we see is that if we add all these up, this is way more than 14 minutes. So like the numbers don't add up. Like what is this actually telling me? Secondly, if I look at this test MDM Apple, I go to my code, test MDM Apple, and we see that this test is just a bunch of subtests, right? So this has like, I don't know, around 40 subtests. So to speed this up, all I do is move a subtest into a different test. Like it's not telling me what I can do to speed up my test suite, right? I mean, the fact that this test, which has a bunch of subtests around for 6 minutes, is not telling me much. Another thing I'm not seeing is which of these tests run in parallel and which are running, hogging up all the CPUs at once, right? Because one way to speed up tests is to run the tests in parallel. So it's not giving me any information about parallelism. So I'm not getting an accurate picture of the numbers. I can't do anything with this big number because I want to see information about subtests, and I'm not seeing anything about parallelism. So for me, this is not really actionable. It's not really actionable. So there's got to be a better way, right? But before we get there, let's talk about we need to understand how parallelism works in GoTest, because that's a big thing. Big way to speed up your test is to run them in parallel. So let's take a look at the diagram. All right, so first we have package level parallelism, right? When you run your tests, when you run your tests, you run your tests, and 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 you r each package gets compiled in its own executable. And when you run go tests, by default, parallelism is enabled. You can specify a -p switch to control it. And by default, it defaults the number of CPUs. So if you've got 20 packages in your repository and you run go test on all those packages, they're going to run in parallel. Each package of tests is going to run in parallel. Then inside each package, we have tests. And those tests by default, they run in series, but you can also run those in parallel by specifying by just calling your t.parallel on those tests, and that will parallelize those tests. And that is controlled with a -parallel switch. Let me see if this, okay, it's not, this doc doesn't mention it, but yeah. So we got -p switch for the packages, and we have the -parallel switch for the individual tests. And each test can have a subtest, like we just saw with one of our tests, right? And each of those tests, by default, runs in series, but you can also parallelize those tests by calling t.parallel. So theoretically, you can have a lot of parallelism, maybe too much in some cases, and you cause overhead switching between different tests. So in this example, we're seeing package run in parallel. We're seeing package 2 run in parallel. And then with test A starts, and then test B runs in parallel as well. They both get dispatched. And then we see test B has subtests which run in series. And then the subtests run and they go back to test B, because after the subtests run, test B can have some additional testing, right? That's how Go tests work. Okay, so given this information and giving our JSON file, let's see what we can do with it. All right, so if we look at the JSON output of our tests, we see things like this. We see the package start, so that's an interesting point of information. We can use this information to see how many packages are running in parallel. We see the test start, that's interesting, test action run, test starts. Then we see a subtest start, okay. Then we see the subtest pause. So from the data I've gathered, pause happens when you call t.parallel, right? And this is an indication that this subtest is going to run in parallel. It pauses, and then another subtest starts running, and that subtest also pauses. So that subtest is running in parallel. So then we see test 1 continue, and then shortly after we see test 2 continue. So we see test 1 and test 2 running in parallel here. And then in the end, they both complete. So we have timestamps here, and we have these actions. So we can use that information to kind of extract the runtime of each subtest, and we can extract which tests are running in parallel. Now, it's not completely accurate. From what I've seen, if the tests are run in series, they don't print their output until the very end of the test, which is a little problematic. Ideally, we'd like to see this last statement, the pass statement, right after the test execution completed, so that we have an actual, accurate time. Luckily, we also have this elapsed information, which could be used, although we're not using this at the moment. Okay, so given this information, we wrote a script that basically parses this file and gets information like how long each subtest is running, and which tests are running in parallel. So let's take a look at our script. Let's see. And the script is not very long. Basically, we're reading information from standard in at this point, and we're unmarshalling every line. We're unmarshalling, and then we're looking for these actions: run, pause, cont, pass, skip. and we're skipping this output and start. Basically, and let's take a look at this. And then after we handle everything, we basically sorts the results and then print them out. And at this point, we're printing out I think the top 50 results. So when we see run, we want to know if it's a subtest. If it's a subtest, what we do is we kind of stop the time for the parent test and start the time for the subtest. Also, we know that subtests by default run in series. So if there's another subtest running, we stop that. So we're trying to keep an accurate time of exactly how much each subtest is taking. All right, and the subtests themselves can have subtests. So we have some recursive code to stop potential subtests of subtests. I think this portion can be optimized a little bit. Pause is simple. We just stop timing that test. Continue is basically restart it. And when we update the execution time, we look at the count of tests that are running, basically tests that aren't stopped. And we have this, what we call adjusted execution time, where we take the time that has passed since the last time we updated, and we divide it by the number of other tests that are running. So we're basically effectively allocating a chunk of time to a test based on how many tests are running in parallel. This is not an exact measurement because we're not seeing the exact CPU time each test is taking, but I think it's a very good approximation. Okay, so the script's not 300 lines, it's not too bad, and this is just a first pass at this point. So let's go ahead and see what results we can get using our script. So it reads from standard in, so we just cat the file, and we pipe it into our script. All right, there we go, and we got our results. So let's take a look at this. The results look, considerably different, like from the Go test some results, and I believe they're more accurate and more actionable. All right, first we have this test. Adjusted time is 8 seconds, and it ran in parallel with approximately 16 other tests. So this 8 seconds means, to me, it means like if we remove this test completely from our test suite, our whole test suite would speed up by about 8 seconds. Next, we see this test. 7.8 seconds. Parallelism is a little low. It's only running parallel with 4 other tests. It's not bad. But also, 8 seconds is not a huge amount of time, when our test suite is 14 minutes. So here we could increase parallelism, or we could increase, or we can just look at the test and try to optimize it and get this time down. And down here, we see a whole bunch of tests that are taking like 5 seconds. So we see these are all migration tests. So this is a kind of prime candidate from perhaps moving them into their own job. And we can see if we add all these up, we could save like, around a minute of runtime. All right. So from these results, we see that there's like small improvements and potentially bigger improvements we can make. But from just overall, like we see that our test suite is not that bad. Like it's okay. We have a lot of things running in parallel. Yes, there's some, especially this one could be optimized. Why is it only running parallel with 2 other things, right? You definitely want to get that one parallelized. But overall, like improving all these tests, it's going to give us seconds of improvement, not minutes. We're running 14 minutes. We want to maybe cut it down to 7. Maybe we want to cut it down to under 5, right? So these results are actionable, but they're actionable in the sense that they're telling us that there's really not huge wins here. With one exception, maybe put these tests into their own job. So from this finding, my conclusion about our test suite is that we really should look at package parallelization, right? We have a bunch of packages. So we should actually split up those packages and running the test for each package in their own test. And that will probably give us the biggest benefit. Splitting it up will probably give us 2x or more, depending how many jobs we split them into. Last thing I want to mention in this warning, right, is our parser found that the test was stopped, but it didn't find when the test was started. So let's look at this one. Test generate MDM Apple successful run. Test generate MDM Apple successful run. Okay. So right away we see something weird here. We see a run command here. So the test started here, but it doesn't correspond to a run action. So we see that the previous output, it looks like an error message that did not have a new line. So, this appears potentially a bug with Go test, right? We output an error, but then somehow it gets combined with the next run message from Go test. And the Go test effectively drops this run message from its JSON output. Now we can fix it by just making sure this error message has an end line. Then everything's fine. All right. So in summary, we created a parser. The parser is on GitHub under Go test stats. It's a first pass at this point, but if people find it useful, we can certainly continue developing it and then getting other people to use it. So definitely like to hear some feedback or suggestions. And that's it for today.